Greetings, everyone. I am Janjobert M. Monsubre.
And I am Elia Ligno, and today we're going to discuss about the topic thermocouple. Today, we are going to discuss about temperature sensor, which is called as thermocouple. So let's get started. So the first question that comes to our mind is, what is a thermocouple? Now, please take note that thermocouple is the widely used, or shall I say, properly used temperature sensor for all purposes. Be it in industries or for environmental parameters, whatever, thermocouple is most commonly used temperature sensor, so it is a very important concept of instrumentation and electronic instrumentation engineering. I advise to listen to it very carefully. So the thermocouple operates on the principle of Seebeck effect. So basically, what a thermocouple is the two dissimilar metals. It consists of two dissimilar metals which are joined together at the two ends to form two junctions. So a thermocouple, it consists of two dissimilar metals just like these, two dissimilar metals which are joined at one end to form a junction they're coupled together. So this is the junction and these are the two different metals. Then, they're coated with a inner layer of silicon dioxide and a silver cover it for as a protective layer. So this is a wired thermocouple. Two dissimilar metals acquires which are connected to form a junction. They're coupled together, then a protective layer of silicon dioxide and a silver cover is given over it. Now, the commonly used metals which are used combination, the two metal wire combinations which are used for fabrication of thermocouple are copper constantan, chromel alumel, platinum rhodium or chromel constantan, etc. So these are the commonly used metals. The two dissimilar metal acquires the material which they are made one of these. So whatever may be the material, the most commonly used metals which are used they belong to one of these listed metals. So the operating principle, so as I said, the thermocouple operates on the principle of Seebeck effect. So they have two dissimilar metals which are joined together to form two junctions at two ends. So here, a closed circuit is formed because of the formation of two junctions and two ends. Now, the principle is that when the two junctions are formed and one of the junctions is heated, an electric potential is developed at the junction. So, because of the generation of the electric potential, a current flows in the closed circuit and that electric potential is proportional to the temperature difference between the two junctions. So, whenever the two junctions are kept at different temperatures, a potential difference gets established between the two junctions. As a result of that, a current flow in the circuit. That's the main operating principle. The electric potential difference is proportional to the surrounding temperatures or the temperature of the entity where the thermocouple is used for measurement, and that produces an electric current which is measured with the help of a galvanometer or a nanometer. So one of the junctions which plays in the region or location where the temperature is to be measured is called as the measurement junction. In the other junction, the temperature of which is kept constant. The other junction's temperature is called as the reference junction. So how a thermocouple works? Here, two junctions are formed. This is the measurement junction, the left-hand side, and this is the heated, or it is placed in the location where the region the temperature is to be measured. The other junction is called as the reference junction. This junction's temperature is kept constant for an accurate measurement. Generally, it is kept in an ice pot at 0 degrees Celsius. This is called as the reference junction because of the heating of the measurement junction. A potential difference gets established between the two junctions, and as a result of that, the current flows in the closed circuit. This is measured with the help of a galvanometer. But here, The voltmeter is used to measure the EMF or the electromotive force of the electric potential directly. You can also use an ammeter or galvanometer for measurement of current or voltage, whatever you can. Here, we are measuring voltage. You can also measure the current by installing an ammeter. So this is the main operating principle. So why an electric potential is actually developed? It is because the concentration of the valence electrons in each metal lead. So why an electric potential is actually developed? It is because the concentration of the valence electrons, one metallic lead becomes positive and the other becomes negative. So they become the two ends of the voltage supply and they behave like that. As a result of that, electric potential difference gets established, just like this positive and negative polarity. If you can see it, so as a result of that, a current flows in the circuit because of the generation of the potential difference, which is proportional to the temperature difference between the two junctions. The potential difference, which is generated between the two junctions, is proportional to the temperature difference between the two junctions.
On the working of thermocouple, we should take note that the only one of the junctions of the thermocouple is heated, and the other junction is usually kept on a constant temperature, normally in an ice bath at 0 degrees Celsius.
And there has to be a mathematical relationship between the EMF generated and the temperature difference. Temperature difference versus EMF generated. The relationship between temperature difference and EMF generated is that T and EMF generated E are related as this formula. The A, B, and C are the thermocouple constants which depend on the two metallic wires which are selected, and T is equal to the difference of TH, which is the heat junction, and the other one is cold junction, which is in a 0 degrees Celsius.
Next is the Seebeck coefficient or sensitivity. S is given by the ratio of E and T, or this formula.
Then we have the common Seebeck coefficient of sensitivity of thermocouple materials, which is used as a metallic wire and has been stated on the table under the material column, while the other metallic wire is platinum. Platinum is constantly used as a metallic wire in a thermocouple. So basically, in a thermocouple, there are two metallic wires. First is the thermocouple materials, and the other one is the platinum, which is constantly used. There are 10 thermocouple materials used as a metallic wire. First is a silicon, which has 440 Seebeck coefficient, chromel, which has 25, iron 18.5, gold and copper has 6.5, rhodium has 6, aluminum has 3.5 Seebeck coefficient, alumel has negative 15, constantan has negative 35, and lastly is bismuth with negative 73 Seebeck coefficient. Next is the cold junction compensation. The thermocouple measure differential temperature, the temperature difference between hot and cold junction. For accurate EMF measurement, cold junction temperature must be known. The cold junction is kept at a constant temperature, usually kept in an ice bath at 0 degrees Celsius. In that case, EMF E is directly related to TH, is given by this formula. Now, the EMF is directly proportional to the cold junction temperature. Because as I have mentioned earlier, the EMF is directly related to the temperature difference between two junctions. Then add the constant temperature, which is 0 degrees Celsius. In that case, we get the formula of E. Always remember that the measurement junction is heated, while the reference junction or cold junction is kept on a constant temperature. This is an example of a cold junction compensation. As you can see, the reference junction is kept on an ice bath at a constant temperature. This whole process is called the cold junction compensation. And lastly are some of the list of the operating temperature range of commonly used thermocouples. These are the combination of positive metal alloy and negative metal alloy respectively. Copper constantan combination has negative 200 to 350 degrees Celsius. Iron constantan combination has the temperature range of 0 to 750 degrees Celsius. Chromel-alumel combination has negative 200 to 1250 degrees Celsius. Chromel constantan has negative 200 to 900 degrees Celsius. As you can see on the table, chromel-alumel and chromel constantan combinations have good temperature range for measurement. These combinations are dependent upon operating conditions or the requirement that is used for thermocouple. Let's have some quick recap. A thermocouple is a sensor that measures temperature. It consists of two different materials joined together in one end. A thermocouple is simple, a cost-effective temperature sensor used in a wide range of temperature measurement processes. Due to their wide range of models and technical specifications, it is extremely important to understand its basic structure and functionality, ranges as to better determine the thermocouple type and material of thermocouple for an application. And that would be all. Thank you.